Ethernet mediator, memory mediator, and a disk mediator. I'm assuming that if for whatever reason you decide not to use one of those mediators, it just means less data into the OTA model,
right?
Or does it just cripple, or does it?
No,
cripple,
it just means it's getting less data.
Gets later, so it still will function missing pieces.
Yes.
Okay.
Or it might use a different path. If it wants to go into memory, it can go in through the PCI Express bus and check memory.
Okay.
The problem with the PCI Express bus, though, is that that can be detected by the adversary. If I come in through the memory mediator...
You're making calls and you can see the calls. If he has
well, no, I don't have to make calls because I can come in... The firmware runs on the coprocessor, not on the host.
Right. Okay.
So as long as...
But how can you detect it if you're on the...
Because I read the host's memory over the PCI Express bus.
But I'm saying that's what I was trying to say is that he could see the activity on the PCI Express bus if you use that method.
Right.
Which is why.
And he can misdirect it. That's with the IOMMU. If I know.
Your board.
Excuse me.
He can denial of service your board and block the memory.
He can block it, but in addition to blocking it, which is what's more insidious, is that he can. If I know that there's for example, let's take a processor mandated data structure, the IDT, the interrupt dispatch table. So he can take the interrupt dispatch table and point it through the IDTR, make another interrupt table somewhere else, but leave the interrupt dispatch table that was loaded with Linux where I believe it ought to be in physical memory. But that's not the dispatch table that the system is using. It's using a new one that I'm not aware of.
Right. Okay. Yeah, that would be bad.
So that's just something that comes to mind quickly.
Okay.
Is there any problem with competition for the bus itself?
No, because PCI Express is not a shared bus. Unlike PCI, PCI Express is point-to-point. There's the end node and the root node. There's nothing else. There's one slot to the root node, another slot to the root node. They don't share the bus. It's a serial bus.
Serial lines between
Dedicated, yeah.
For each. What was it? Paths or channels or something? You said?
Lanes.
Or lanes.
They're lanes.
It's a dedicated serial bus for each.
Yeah, and it's they're differential. So there's a transmit and a receive pair, differential pair for each lane. Transmit and receive pair for each lane.
Using this imply there's some restriction on the software application. I mean, if I program a certain way, I will trigger it and make the false alarm.
If you program what?
The software application.
The software application running on the host?
Could you write a program that would destroy, would trip off the sensors inadvertently as an honest programmer?
Let's say you're doing an upgrade to your software.
Excuse me?
Let's say you're doing an upgrade to your software and it changes the operation.
An upgrade. You have to, there's a provision that says secure coprocessor, we are updating the software. Right, so there you need an administrator to notify the system that the software is going to be upgraded, and then it has to rescan and reestablish its tables to the new upgrade.
I guess that would probably answer your question too.
Excuse me?
That sounds like it answers his question also. Like if you wrote some custom software or were testing something, when you went to test it, you tell it this is okay. Is that correct? Or?
You could do that. Yeah.
Okay.
So if I'm a bad person, why wouldn't I just do that?
Excuse me?
If I'm a bad, evil person, why wouldn't I just say, hey, I'm updating the software?
You can't tell it that you're going to do an upgrade without having the proper authorization and authentication. So you need to have a key to encrypt a message to the coprocessor that it will then decrypt and take actions. Now, if the administrator does not protect his keys, Yeah. Yeah.
What would be your recommendations for protecting the keys? How would they do it? USB stick and a tiger?
Yeah. I mean,
I don't want to do an update. You know, tiger's in the cage with the USB stick. Yeah. Okay. All right.
You need that. How do you? No, I think you should do. Personally, I think you need you should use a key and a biometric.
Oh, okay.
You know, but you know, a fingerprint or maybe a couple of fingerprints and a biometric. A biometric and the key. So,
right.
so when you take a fingerprint, what happens is that most fingerprint systems put together what's called a minutia map.
Mm-hmm.
So you take that minutia map, encrypt it with your key, and send it.
Do you support optical sensors?
Sure.
Optical scans? Okay.
And then the co-processor takes the fingerprint minutia map, matches it to the finger it has stored, and the key. So it's not enough to know the key, you also have to have the finger. Alternately, you can use an iris. You know, there's lots of biometrics that you can use.
Right.
But the disadvantage to that is, of course, that you have to be, you have to have access to these additional technologies.
Right.
But it does, you know, increase the protection of the keys, right?
Just an overview, how do you get sort of so close to the hardware in all this?
Excuse me?
How do you get so close to the underlying hardware in all this?
How do I get so close?
Yeah.
We build the circuit cards.
Goes through the PCI Express.
We go through the PCI Express and we have electrical engineers that design the electronics.
Because I think it's. Can I take a guess at what he's asking?
Sure.
Try to answer it how I think he's asking it, which is I think it might be that a combination of none of the internals of a PC, none of the bus internals or controller internals are written with security in mind, so they can just walk in because they're already in the machine physically, and also because they have components of the operating system which let them stare at the operating system. You know, they have software that actually runs on the operating system and watches as things change.
Yeah, no, and
asks
the
questions.
latencies that are induced by all this are in what order?
I'm sorry, I can't hear you.
What was that again?
Latencies, the sort of latencies that are induced by all this, because you talk about close to real time.
Well, that's what I said earlier.
Yeah.
Because this firmware is executing on its own processor, it minimizes the effect on the host.
So rough order of magnitude for the latencies that you're talking about? For various operations? I mean...
Well, the only one that could have some impact is when you're, for example, the data structures that go to the disks are called frame information structures, FISs. When a FIS is sent to a hard disk and we examine it, we're talking on microseconds in the examination to come to a decision. But keep in mind, especially with the disk, that the software back in the host is anticipating a large delay because there's mechanical movement. There's the rotational delay, the boom movement. So, a few extra microseconds is not going to be detected, even with buffering on the disk.
Yeah, no, but for disk-based systems, but
Excuse me?
for disk-based systems, yeah, but for systems.
Now consider memory, right?
Yeah.
So memory, when we come in, we don't come in on the system bus.
So let's say the thing has been armed, right? You know, it's been totally. It has a snapshot of how the system should look. It's all possible watching controls are on. So data is passing through the PCI Express bus, and passing through memory, and the Ethernet port's probably the easiest of the three. And you're watching it go by, and let's put it in terms of like Cisco networking. You know, they like to brag about their their switches and their routers, you know, they don't do store and forward. They don't move whole packets. They just scan enough of the packet to get to a point where they're satisfied that it's this or that, and then it just literally flashes right through this. Is it similar to that? I mean, you're just observing, you're just tapping off the line and watching the same bits as they pass by, right?
Right. So there's
You're not introducing any overhead at all. It's just you just literally.
Right.
Because of the nature of the way the PCI Express bus is built. So this is really in a way a PCI Express bus technology. It wouldn't have been possible before that.
Keep in mind, though, that when I keep talking about the memory mediators. Now, if you want to say that the memory mediator is not available, then yeah, it's going to go through PCI Express. But once the memory mediator is available, we don't need the PCI Express bus anymore, other than for power.
Right.
Because then you can reach right into physical memory without going through the PCI Express bus.
And once you have that piece of software running in the operating system, they can.
No.
Oh no, it's
software.
not. It's not software. Oh, okay. The memory mediators.
The memory mediator
Where does
is
it
hardware.
Right. Oh, the actual memory controller chip. Once you have access to that.
No.
Okay. I don't know what the memory mediator is.
So essentially, memory, the DIMMs that sit on the system bus
Right.
are controlled by a memory controller that in these days it's inside the processor chip. And so there's a system bus that controls accesses to that memory.
Right.
So assume that the system bus is at the bottom of my hand. We then add logic to those DIMMs that sits on top that goes to our card. So we're not interfering with the system bus. We come in from the top. We've designed those DIMMs to let us come in from the outside.
Oh, you have a second bus on your special DIMM.
A special DIMMs.
Oh.
A special bus.
Okay, now I feel much. I thought it was stupid. Okay, that makes much more sense. I'm like, how are you seeing this without?
Basically dual port memory?
So the memory's
dual
talking
port
to two
memory
places.
was one way to implement it, but it essentially says that I now do not. I am virtually undetectable. Right?
Wow.
Virtually undetectable. Because I can come in,
awesome.
read and
I
write
didn't know that.
without executing, without consuming a single host cycle, or interfere with the system bus as it's transferring back and forth.
Do you have problems with latency on your bus? Because of course the physical memory may actually be further from your card than it is from the actual system processor. Do you have ever had latency problems on the bus between the DIMMs and your card?
I haven't really exposed the details of the
You got it under
implementation.
control.
Right. So
Okay.
first of all, you're making an assumption that I'm going to keep the memory DIMMs on.
You'd set it over on secure Wi-Fi for all I know.
Yeah.
Little antenna sticking up from your DIMM. Okay.
Okay. I mean, keep in mind that we do have technology that
Right.
that samples
Well,
radar echoes, right?
Deliver your first non-government client, of course, they'll probably put it up on YouTube, and then everyone will see what you're doing. But.
Well, you can see it, but you can't look inside.
Yeah, no, I'm talking about the ribbon or whatever
Yeah.
going from the DIMM.
Again, the same problem. If someone can open the box and disconnect the ribbon, of course, we'll know they disconnected the ribbon. That's going to have electrical consequences to the secure code processor.
Right.
But first of all, we'll know.
Oh no, I wasn't talking about that. I wasn't talking about the security. I'm just talking about the physical link, because I know that you get actuation and induction and that kind of junk when you have too long a cable. And that's the reason why the DIMMs are always right on top of the processor. So you managed to overcome those problems? Nice. Okay. That was
Okay. So again, this is a very, very, very simplified block diagram. But the thing I want to stress again is that these are fundamental physical capabilities. It's only when you couple these capabilities with in-depth knowledge of your target and how it operates that you can provide very powerful and very elegant protections and guarantees. For example, with with the SATA mediator, you can guarantee integrity of files because you have a backup, an instantaneous backup, that if all else fails, you could use the backup that's on the secure coprocessor's disk to provide. So let me, I didn't stress that as a capability. Let's see. Okay, so what I talked about was the situation where something comes across here and you decide that it's there's something about it that request that's offensive, and you decide to block it. But there's another use. Suppose the host system dies. Because the secure coprocessor has a pristine repository, copy of disks, it has the capability of intercepting, and it knows that this host disk is dead because it can see what's going on. It can then take those requests that are meant to go here and respond through this path to the host processor supplying the data and make it look like it came from there, even though it has not. Because there's no way for the host bus adapter to know where the data originated from. We are transparent. We're invisible to the host bus adapter.
Which goes back to what I was saying before about how all the subsystems on the motherboard work on the assumption that everything inside the box is trusted.
Yeah.
Yeah, how frequently is the secure disk updated? The pristine repository.
That was the question that we answered. The secure disk is updated dependent upon your application. It can be updated continuously. You could use it in the same way that you might use a backup, a online backup disk. And every time there's a write to selected files, update your copy of the file also.
So the pristine repository can actually be updated dynamically without me having to even press a button.
Right.
Oh, that's fantastic.
I keep stressing that what's being presented here is the low-level capability. How it's used is application specific. So for those people who want to have a fresh copy, should you have a head crash on your host disk, you can have an instantaneous fresh copy by then switching to the secure coprocessor's copy. And without any knowledge on the part of the software. All that needs to happen is you have to, of course, have planned for this. And then the secure coprocessor to the SATA mediator notices that the host disk drive is no longer responding. It's timing out, continuously timing out and no longer responding. It can then be, once you've configured the system for it, it then takes over and it will start providing the data as though it were the host disk drive.
That's with the idea of real-time systems in mind, right? Because you were talking about how this is for the initial sort of impetus for this was sort of military applications, where you imagine like a tank or a plane or something like that.
Well,
where
it could be medical systems.
Or it could be medical systems, right? But I guess the idea was that how long something that we all sort of in the computer field don't sometimes think about the idea of, oh, I'm gonna have to go and let's say my disk gets wiped for whatever reason, I'm going to have to go and get everything working again. The idea that, this is something that is continuously being backed up and then could dynamically, work as a backup while the failure is happening is that's something I had not anticipated.
Excuse me?
It's like a sysadmin on a chip.
But somebody might have to design something to be highly available and reliable. They're not going to rely on that to make it reliable and available. Yeah. They're going to design it with a mirrored rate or whatever they need, extra processors or whatever, This, you really want to essentially keep somebody from sabotaging something or taking a system over, right? That's the that's the idea of it.
The idea
not
is
a backup.
definitely to fight against sabotage and espionage. That's the intent of the system. Yeah. Now, can it be used in those other? Of course.
You can fill in for other
Of course.
things, but you can do the other things probably a lot more easily and cheaper, you know, with items meant to do those purposes.
Right.
Do you have any paying customers yet? Is one of these?
We only have one customer right now, and that's AFRL, Air Force Research Laboratory. And it's them and the
Oh, it's just the Air Force.
Excuse me?
Oh, it's just the Air Force. No big deal.
Yeah, the Air Force and the and OSD, Office of the Secretary of Defense. We've done a presentation to the Trident group, the Navy Trident group, and they're very interested in it also. But you know, it's well, we haven't done any ad. You know, we've been spending all our time doing engineering.
You remember that one of the developers was showing off and sent his code to someone. Oh yeah, I can write that faster. Oh yeah, no you can't. Yes I did. Look here. Oops, fired.
Thank you.
Yeah, he got caught, but he might not have. Very easy.
Might not have. Sure. Yeah. So we've done very little marketing. So yeah, we're approaching the phase now where we're going to start marketing and pushing. And there's, in addition to this technology, the anti-tamper technology that we passed around is another potential product for engineering firms that want to protect circuitries. Now, besides that, you know, that membrane, that those traces are printed with conductive ink, and it's very inexpensive. That sheet was roughly $100. The next technology that's available is up to $500–600 roughly. But because it's so inexpensive, we can print multiple patterns for the same. For example, our card, we could have multiple patterns of that sheet, so that if someone has deciphered a weakness in one pattern, the next card may have a totally different pattern. I'm sorry.
A little background about the company.
Background about the company?
Yeah.
Yeah, it's a small company. It's myself, 3 other investors, John Leonardos, who recently left, Chris, who's behind David, and David, who is our legal counsel now. Well, no. He's our future legal counsel.
I think we call that retainer.
Todd, who's our program manager. John Davison, who's also a consultant and a image processing and DSP expert. And Steve Weingart, who is a cybersecurity expert in physical protections. And
most of the companies here.
Yeah.
Terrific. And how many years have you been doing this?
About 7.
As a group, 7.
About 7. We've done, in addition, you know, we really do embedded systems.
So China will come out with their version of what you're doing very thoroughly.
And so we've also done, in addition to this, we've done another a PCI version without the physical protections. We've done an MRI controller. We've done that. We've also done a system that can track electronic equipment in a data center or a lab simply by, when you plug it in, we use the wiring in the building as a Ethernet network, and it tells us what outlet you plugged in, what piece of equipment. So we've got a patent on that. So, and combat systems, we've also done an AFIS, the automatic fingerprint identification system that's used in the national ID system in Spain, in Costa Rica, and in Dominican Republic. John Davidson has done the design of a fingerprint classifier and a WSQ, a wavelet compression algorithm that's been certified by the FBI. So we've done a number of things. We're a small company. We're outside investors also. Any other questions?
No.
That's pretty good. Let me see if.
How much is it?
Yeah, I knew that was going to happen.
So it's comparable to the mid-range machine.
Yeah.
Nice.
Yeah.
Okay.
How old is the IBM system, and when was the last time it was updated?
Maybe Steve.
It came out in '97. The current one they're shipping is the 4th or 5th generation, and it's within a year or two. I mean, they've been using the same architecture and improving it and spinning it for higher performance every couple of years. One of the biggest differences between the IBM version and the SiCore version is the fact that IBM discourages letting other people into the programming environment, though they've done it for some huge customers, and let them develop their own code, is where that's kind of the basis of the SiCore approach, is that they're assuming that people need to put their algorithms to be protected. The IBM device has kind of devolved into a service machine, as where this is more of an open general purpose environment that the customer would put their own, vendor specific intellectual property in there.
Okay. Any other questions?
Thank you very much.
Okay.
Well, thank you everyone for coming to Lilac, and it's 10 o'clock now, so I guess the meeting is adjourned, and go get some more coffee.